Good evening everyone. So welcome to this week 11 discussion class for the course of Design of Photovoltaic System. This this course is being taken by Professor L. Umanam from Department of Electronic System Engineering, IISc Bangalore. And I am Ravi Kumar, a PMRF research scholar at IIT Bangalore. So up till now we have understood what a PV system is, what are the IV characteristics of a PV systems are, and how we have storage media like battery, and how we have different application using this solar PV. So we have understood about the Peltier system, integration of Peltier system, and then integration of pumped hydro or different pump we have seen in the last class. So in this class we are going to talk about this grid integration. First of all, we need to understand why we require a grid here. So we know solar PV is not present 24/7. So we need some media in which we can store this energy, and then we can utilize this energy later on. So for the storage things we have battery, pump hydro, etc. So these are the one side or the applications which we can utilize as a storage medium. Other than that, grid also can be used in the absence of solar PV. It's like if there is no sunlight, we can take energy from the grid. And then so grid, what is grid is? Grid is an ideal source with zero impedance. It means any amount of power can be drawn from this grid. That is the characteristics of a grid. So also in case of excess generation in daytime, when there is excess generation, or we can say we are feeding to the grid only, so the power generated by PV can be given back to this grid. So this today's lecture is all about this grid integration. But how can we connect? Can we have solar PV? Let's say this is a solar PV module. And these, let's say these are the outputs. And this is, let's say, grid. This is the grid we have. Can we connect those directly to the grid? It is all about integration. Can we connect output of solar PV directly to grid? So here what we are doing, we are trying to feed the power to the grid. But can we do so directly? No. Because we will understand now why we cannot connect PV module directly to the grid. So first of all, let's understand some grid principles. So grid is a voltage source, and any amount of current can be drawn. It depends on the application. So grid is a source of infinite energy, we can say, and the voltage remains the constant. And that's why a voltage source directly to the grid cannot be connected, because you cannot connect two voltage sources directly? No. So how can we feed the power to the grid then? We understand that a current source can be connected to the grid directly. So what we need to do? We need to convert solar PV as a current source. So first of all, we need to convert this solar PV output as a current source, then only we can integrate it with the grid. So first it needs to be converted from voltage source to a current source, and this is done by using an inductor. So this is our PV side, this is our grid, and if we have an inductor, then the Kirchhoff law will say Vg plus Vm equals to V. So before integrating a solar PV system to the grid, we require an inductor, and this inductor converts this entire thing as a current source. So this entire lecture or discussion is based on this only, how we integrate solar PV to the grid. And also there are two important things as well. It's like the phase of current and voltage. The phase of current and voltage should same, then only maximum power can be obtained. And using this relation only Vg by Vn, if we just do some mathematics, so this is the condition which need to fulfilled by this Vi, that is a PV source. Okay, now let's see, like between this PV module and this grid, what are the components we have in between and how we integrate. So there are different topologies by which this PV can be interfaced or integrated with grid. So we have some isolation, number of power stages, dynamic controls. So it is having like high frequency, low frequency transformer, different stages converting from one type to the another type, then control of dynamics based on static or dynamic. So these are just type of topology we have, and how we connect. Here we can see this is a PV module. So first it is convert using a DC-DC converter. It make to work at MPPT. So it is maximum power point tracking here. Then voltage and current are controlled using another DC-DC controller. Then we obtain this kind of waveform, and then we convert it into this kind of waveform from DC to AC, and this AC then phase matching and frequency matching. So by obtaining these two things, it is fed up to the grid. And this is how this unfold work. So this entire circle is for this unfold circuit. So this is already discussed in class in detail. You can go through the lectures if you have not gone through yet. Then similarly we have three-phase connections. So from this DC-DC converter we take out three-phase and three inductor, and using this three inductor we have three-phase, different three phases. So like exact circuit for this three-phase grid connection is like this. We have different controller which control the current and all, because we need to match the frequency and phase. And this is for the three phase, this is for the single phase. So this is already discussed in the class. We will solve questions based on this. Before like going to the questions, I will just tell you some things. Like in the three-phase system, what happens? We have three different voltages, or we can say current. So they are having different phases. So one is like minus 120 degree behind, one is plus 120 forward. So these are the three-phase system. In the two-phase system, it is 90 degree. And then we have different, like from DC to AC conversion, we have like AC to DC conversion, alpha, beta. So it is based on the axis, as you have gone through the class. So these are just formula or the matrix form, how we convert this ABC form into alpha, beta, then back this alpha, beta back to this ABC form. Then we have this DQ form into alpha, beta form, and then we have this alpha, beta form into DQ form. So this is all about the conversion of this signal voltage or current from one form to the other. I have given these formulas because we will be utilizing these formulas in solving the questions. Okay, now let's solve the first question. This question says, in a stationary frame of reference, when three-phase to two-phase transformation is carried out, the voltage at the alpha axis is expressed at, we can say, okay, first let me read the question. And the voltage at the beta axis is expressed as this way. Determine the expression for the phase A of three-phase system voltage when it is aligned with the alpha axis. And these are the options. So first of all, we need to find out what are the things already given here. So we have been given, we can say alpha as 100 sine 100 pi t. Then we have given the beta. This is a voltage alpha, voltage beta. It is also 100 sine 100 pi t plus pi by t, because it is two-phase system. Then this is asking VA, phase A. This is asking this one. So here we need a conversion mechanism which convert alpha beta into A, B, C form. So this is the particular matrix we need to utilize here. So let's see. Alpha beta, this is the matrix, alpha beta into ABC. So we will be utilizing this one. So this is the matrix which we will be utilizing, and here it is asking only this VA. So we will not go to VB and VC. So we, from this matrix only, this VA will be 2 by 3 V alpha plus 0 into V beta. So it is 2 by 3 of V alpha. And what is this V alpha is? From here we can get this V alpha. So this V alpha is 2.3 equals to 100 sine 100 pi t. So it is 66.67 sine 100 pi t. So this is V, and it matches with option A. So here correct answer is option A. Let's move to the next question, which says determine the total impedance in milliohms seen from the primary side. So here in this seen from the primary side of a transformer operating at a frequency of 50 Hz, when a secondary side is sorted, given primary leakage inductance 0.06 and secondary is 0.08 and a magnetizing inductance is 2, assume that transformer resistance is negligible, and these are the options. These are the options. So this is the primary side. This is the secondary side. Question says already sorted. So we have this L1, L2, L3. So first of all we will find out L equivalent. L equivalent, inductance equivalent. So here L1 is in which series plus we have L2 and L3 in parallel. So similar to the resistance, here also parallel combination will be same. So it will be like L2 L3 divided by L2 plus L3. So let's put the values here. 0.06 plus how much is L2? 0.08 into 2 divided by 0.08 plus 2. So how much it is coming? How much it is coming then? Okay, let me do the mathematics. .08 into 2 divided by 2.08 plus 0.06. It is coming 0.1369 millihenry. L equivalent. It is asking about the inductance. So this inductance will be omega L. omega frequency is given in hertz, so 2 pi f l. So it is 2 into 3.14 into 50 into 0.1369 milli ohm. Into 2 into 4 into 3.14 into 50. It is coming around 43 milli ohms. So this is the value of total impedance in milliohms. 43 is C. So correct answer here is C. Okay, let's move to the next question, which says, for the following ABC signal as VA, VB and VC, find the value of mode alpha plus mode beta. Value of T is given 1 by 200, and these are the options. So first of all, here we need to convert this ABC into alpha beta, then take the mode and add them. That's it. So which matrix here we need to utilize? Which converts A, B, C into alpha beta. This is the matrix which we require. So first of all, we will see the matrix. So this is the matrix which convert this A, B, C into alpha beta. And then we need to take mode of alpha, mode of beta, and then add them. So let's solve this. V alpha V beta equals to V A minus VB by 2 minus VC by 2. And in this case, it is root 3 by 2 VB minus root 3 by 2 VC. And this VA, VB and VC already given. Here we require the value of T. T is given as 1 by 200. So just put the value of VA, VB, VC. Okay, let me put. So VA is 20 sine I'm solving for 50 pi by 200 minus it is VB is 20, so it is 10 divided by 2, 10 sine 50 pi by 200 minus 2 by 3. Similarly here 10 sine 5 50 it is 50 pi by 200 plus 2 by 3. Similarly for this V beta, root 3 by 2 into 20 into sine 50 pi by 200 minus 2 pi by 3 minus root 3 by 2 into 20 into sine 50 pi by 200 plus 2 pi by 3. So what our V alpha and V beta is? We just need to solve this. If you wish to solve them, then solve it. I am also solving. Sine 50 180 into 50 divided by 400. So it is coming like 20 sine 45 degree minus 45 minus 120. Ten sine minus 75 minus 10 sine 165. And this case is 10 root 3 sine minus 75 minus 10 root 3 sine 165 degree. No, actually this is in angle only. Everything is angle. So like if it is given in case of an angle, then we will take in degree only. It's like 2 pi by 3. So here pi cannot be in radian, because here 2 pi by 3 is 120. That's why we are taking it in degree only. Okay, so let me solve further. At some places when I use degree, answer is made wrong and I got 0. Why so? Let me check what I am getting. I'm getting 21.213. So when to use radian, when not in radian. See, you here from the question itself, you can see VB is how much? 50 pi t minus 2 pi by 3. So here we can see this VA, VB, VC are 3 phases, and we understand the 3 phases, the difference from 1 should be plus 120 and minus 120. So we totally understand here, like 2 pi by 3 is 120, and this 2 pi by 3 is 120, then pi here is 180. For the beta side, sine minus 75 into 10 into root 3 minus 16 minus 10 into root 3 into sine 160, and this is I am getting minus 21.213, and question says the mode of alpha and mode of beta. So mode of V alpha plus mode of V beta equals to 21.213 plus 21.213, which is coming to be 42.42. So the answer should be B. Answer should be B. This radian and this degree, so you can understand by seeing the question only. If 2 pi by 3 is 120, then pi should be 180. Okay, let's move to the next question, which says from the similar question 3, find the value of mode D and mode Q for rho is given 25 pi t and t is given 1 by 100, and these are the options. So what we need to do here? First we need to convert our A, B, C into alpha beta, and then this alpha beta need to convert into DQ form. So there will be 2 matrices here. First, similarly we have done in the previous question, we have converted this ABC into alpha beta form, and then we will convert this alpha beta into DQ form using this particular matrix. So without doing the matrix thing, I am just writing directly here. So our V alpha comes to be VA minus VB by 2 minus VC by 2, and our V beta comes to be root 3 by 2 VB minus root 3 by 2 VC. So this is the conversion already done from ABC to the alpha beta. Now for V alpha, so first of all we will get this V alpha and V beta only, and then we put this V alpha V beta here, then we can get the question answer directly. So let's find out this V alpha at t equals to 1 by 100. So it's like from the previous question only, 20 sine, that was 50. See, in the previous question it was 50 pi by t. So if you put t here as 100, so it will be pi by 2. So I am putting t equals to 1 by 100 in this case. So then I am getting 20 sine pi by 2 minus 1 by 2 20 sine pi by 2 minus 2 pi by 3 and minus 20 by 2 sine pi by 2 plus 2 pi by 3. So this is the one thing. What will okay, this matrix also will require. So if you solve this, what will you get? Just put the value of pi and get me the answer. It's like 20 sine 90 minus 10 sine 90 minus 120 minus 30 minus 10 sine, it's like 90 plus 120 to 10. Put the value in degree and get me the answer. It is like 20. So it is 1. So it is like minus 0.5 and it is also minus 0.5. So this minus minus will be positive. So it is 5, 5, 20, it is 30. So we are getting V alpha as 30 and V beta root 3 by 2. What we are getting here, it will be same, into 20 into 0.5 negative, and also here minus root 3 by 2, 20 into sine, sorry, not sine, I am writing directly, minus 0.5. So it's like positive, negative, it is 0. So V beta is coming to be 0. So now we will put here like it is 30, it is 0. Okay. Now we will solve for this. So our VD and VQ. So it is coming to be 30 cos. What is the value of rho? 25 into 180 divided by 100. 1, 4, it's like 45. Pi by 4 only. Yes. So cos 40 and this is 0. Similarly, VQ is 30 into minus sine 45. So 45 cos and 45 sine value are same. So it is like 1 by root 2, 30 by root 2 and minus 30 by root 2. So we need to find out mod VD plus VQ mod. What is the answer then? 30 divided by root 2. It is coming to be 42.43, because mod will be like this plus this, and these are the same quantity. So if you will do 30 divided by root 2, you will get 21.21 something, then just multiply by 2, you will get this one. So it is 42.43. Correct answer is D. So here we need to convert it from one form to the another form. Okay, now let's move to the next question, which says, from the question number 3, find the value of mod D and mod Q when rho is 50 pi t. It is saying 50 pi t, t is same, so our rho value will change. Rho was 45, then it will be 19 in this case, because it is twice. In the previous question it was 25, it is 50 here, and these are the options. So rather than solving the entire question, we can just move to the last step and we can change the value of this rho. So here we was getting 30 and 0, it is already known. So this 30 and 0 will be same because t is same. So here we are just changing the rho. So this rho will affect this particular value, this cos value and sine value. So our BD and VQ will be like this: 30 cos 90 and it will be negative 30 sine 90. Yes, cos 90 is, what is the value of cos 90? It is 0. And sine 90 is 1. So our VD, VQ form will be 0 minus 30. And if we take the mode of VD plus mode of VQ, it will be 0 plus 30, it is 30. So 30 should be the answer here. Let me check. Yes, C, 30 is the correct answer. So here it is all about the matrix. If you know the conversion matrix, you can solve these questions easily. Now let's go to the next question, which says select the frequencies present in VD expression if rho is 200 pi t from the following option for the ABC reference frame. And these are the options. This is also so simple. Here you need to find out the frequency of DQ frame and then frequency of ABC frame, and the difference will be the answer. So here it is given VD expression this, and VA expression was, as you remember from the question number 3, VA was around like this. Let's say 20 sine 50 pi t. It was like this. So generally we write an expression in terms of omega like this, sine omega t. Omega is an angular velocity, and if we just change it omega into f, so we write it as 2 pi f. And if you just compare with this 2 pi f, you can get this frequency. So from this VA, 50 pi comparing with this 2 pi f, we get frequency of A equals to 25 Hertz. Similarly, for this rho, for the VD expression, it is 200. So frequency of D we get 100 because it is 2 pi f t. So it is 100 Hertz. So the difference between this FD minus FA is 100 minus 25 Hertz. It is coming to be 75 Hertz. So our this VD expression frequency should be 75 Hertz. So answer here is C. Now let's move to the next question. So this question says, in a balanced three-phase grid connected inverter feeding from a PV system, VG is a resultant grid voltage. This VG is the resultant grid voltage. This G, this is the VG. IG is the resultant grid current, and IG is the resultant grid current. Space vector of a three-phase system. If power from the PV to the grid need to be delivered at the unity power factor. Unity power factor means maximum, we can say. Which statement is correct for the condition of DQ frame when phase A of the grid is aligned along the D axis? So A is aligned with the D axis. You need to find out the correct options. If this is a DQ frame system, this one, and VG is aligned this D axis, and let's say I is here, to be maximum, this I need to be maximum towards this D axis. So the component towards this Q axis should be it should be 0. See, this IG can have two components, one D axis, one Q axis. But to be maximum, our VG is this side. To be maximum, it should be in the D axis side. So this particular condition make this Q will 0. The Q component of current and Q component of voltage would be 0. Then only the maximum power can be obtained along this D axis. So along Q axis, 0 should be IG and 0 should be VG. It means current component and the voltage component along the Q axis should be 0. Then only we can have the maximum power. So correct answer here is B and D. So simple. Next question. Select the accurate statement regarding the utilizing an unfolding circuit to integrate the photovoltaic system with a grid, and these are the options. This is so simple. I think I should not tell you the answer directly. You should try this. The unfolding circuit. What is the role of this unfolding circuit? Something is folding like this and you are unfolding it like something. Mohan said B. Unfolding circuit converts the DC waveform from the DC-DC converter to the AC waveform. Okay. And that is correct. Here you can see this is an unfold system. This is our DC component, this is our AC component. So it converts DC into AC. Converts DC waveform from DC-DC converter to the AC waveform. So from DC-DC converter, it is coming DC, it converts into AC using this unfold system. And this is the correct answer. Let's move to the next question. What is the use of PLL circuit in the grid integration with the photovoltaic system? And these are the options. PLL, that is the phase lock loop. Okay, A and C. Yes. So what are the requirements when we put some power to the grid? So first is frequency and second is phase. So this phase and frequency should match, and that is the role of this PLL circuit. So it determines the grid voltage phase angle. It getting the speed of machine, no? Which machine? No. For determination of grid voltage frequency, yes. So these are the two components which are obtained by this PLL circuit, and A and C are the correct answer. Let's move to the next and last question. It says, let's PDQ, it is the power in DQ form, be defined in DQ domain, and PABC is defined in the ABC domain. So this is the power in DQ domain and this is the power in ABC domain. What is the value of K in the above equation if power should remain the same in both domains? If PDQ is equals to PABC, and consider three phase balance current and voltages, and these are the options are not correctly written. Let me write 0.43, 0.63, not 6, 66, 0.77, 0.88. These are the options. So there are only given three conditions. So first of all, we have given that for the balance current and voltage things, we have VA plus VP plus VC equals to 0. Similarly, we have IA plus IB plus IC equals to 0. Then one thing they have given that power in DQ form will be equals in power in ABC. So first of all, we will write power DQ form in terms of A, B, C. So for this we need voltage and current both. So we will write VD as a cos rho VA minus VB by 2 minus VC by plus sin rho VB root 3 by 2 minus VC root 3 by 2. So it's like from ABC to alpha beta and from alpha beta to DQ. So it is a direct conversion from ABC to the DQ form. Similarly, for VQ, it's like minus sin rho VA minus VB by 2 minus VC by 2 plus cos rho VB root 3 by 2 minus VC root 3 by 2. Similarly, change V with the I, you will get equation for current as well. Then write power dQ as K VD ID plus VQ IQ. VD, put VD from here, VQ from here. Similarly, by changing this V with the I, we can get in items of ID and IQ as well. So now using this equation like 1, 2 and 3. Using these three equations, if we do the mathematics, we will get one thing, that is PDQ equals to 2 by 3 VA IA plus VB IB plus VC IC. And if you just compare it, with power, we know this power in DQ will be equals to power in ABC fields. So the factor here it is coming to be 2 by 3. So this factor is only this value of K. Even you also can see, even if you don't want to do all the things like this, we also know in the coordinate system, this one correspond to the 2/3 of another system. So value of 1 in one coordinate system correspond to the 2/3 of the other coordinate system. That's why the power factor should be there as well. So one will be have a power of 2 by 3rd of the another. So this way K should be 2 by 3 equals to how much? 0.66, similar to the first question. So it is the value of K here. So correct answer should be So in this particular lecture, there is only problems based on the conversion of one coordinate system to the another coordinate system, and that too depends on the matrix. If you know the matrix, you can solve them easily. In the next class, we will see, and that class will be officially last class for this course, and in that class we will see LCC and all. And after that, I am also taking one extra class, most probably on Saturday. So in this in particular that Saturday class, we will like design a solar PV system for our home. So we will sit together, we will calculate the load, and we will do all required calculation. We will find out the battery storage, we will find out the amount of PV module we require, everything. So that we will do on Saturday class. So this is all about today. We will meet next Friday and next Saturday. You will be like informed via this. You will be informed via NPTEL platform, and you will get the link. Most probably same link will work, but if there is any change with the link, you will get the link from the NPTEL platform. Thank you. Today's link, yes, I will upload this video now in next 15 to 20 minutes, and then I'm just sharing the link where you can find the video. So in the chat box, this is the link. Video will be available in this link within like 15 to 20 minutes, whatever the time the uploading will take. Yes, Mohan, what you are saying to include in the Saturday class? Mounting structure design. Okay. I'll try to wind load and snow load. Okay. So I will introduce you some defects and degradation as well in the Saturday class. As you must know, like I am a researcher in the field of photovoltaics, and I am working on this reliability issues of photovoltaic PV module. Battery frame for the load. Okay, I will try to find out some content on this as well. So Saturday class will be a bonus class. Okay, thank you everyone. If you wish to, you can leave. Bye. Bye, Mohan.